Hi, welcome to this demo video where I will go over how to use the PhET simulation radiometric dating for these demonstration objects, a bone, a rock, and then a fish fossil. Okay, so first thing is when you get to your PhET simulation, you have this is your Geiger counter, and to test the percent of radioactive isotope in the object, you're going to move the Geiger counter onto the object. Okay. Now, when you move the Geiger counter onto the object, you know that it's working when this window pops up. So if I move it, like let's say I move it here and I'm like ready to test it out, notice that there's a line that's telling me that I didn't move it onto the object. So I just need to make sure it's directly on, and when this window pops up, I know it's working. Okay, so you'll notice that the Geiger counter tells you the percent of the isotope, and there are different isotopes here. There's carbon-14, uranium, and then also a custom isotope where you can customize the half-life of the isotope. And we'll look at that later. So in order to determine the age of the isotope, the Geiger counter just tells us the percent of carbon-14 left in it, 83.9%. Remember, we need to match that percent to a percent in the half-life data table. Now, there's no data table here. Well, there's no data table, but there is a graph. And so we're going to use this graph sort of like we used the data table in previous problems. So remember in previous problems, if I go down to the problems here, for example, you would find the percent in the table that matches it and then use the corresponding time. Well, that's what we're going to do. We're going to move this cursor over so that the percent of our isotope, you see that 51.9 or whatever, that percent at the top matches the percent that we see in our Geiger counter. All right, so my percent of carbon-14 in this bone is 83.9, so I need to move this, I'm going to move it to the left so that the percent goes up. But right now it's like 56%. I need it to go to 83.9. Okay, and it may not be perfect, so 84.1 is pretty close. So now that I have it matching close enough to that percent, I'm going to use that time there, 1427 years. Okay, so that tells me that this bone is 1,427 years. So I'm going to go ahead and click on that in the box, and I'm going to type that estimate in just to check it. Great, I get a bing, and you see that happy smiley face. That tells me that that's correct. So now what do? I want this data in my table, so I'm going to go to my lab. Let me go ahead and scroll up. And under the bone, I'm going to write this value, 1,400, and what was the number again? 27. Great. So that tells me that this bone is 1,427 years old. Now let's go ahead and type in the age for this rock. I'm going to go ahead and just put years here. Okay, just so we know what that means. Okay, now we're going to do that for the rock here. So I go to my simulation and I look for the rock. Here it is. It's the big gray, dark gray one. And I put my Geiger counter on. Notice that there's a pop-up window, so the Geiger counter is on and it's working. But when I go over here, I see that it says 0%. Now, if there's 0% of carbon-14 of that radioactive isotope in this rock, that means I cannot use carbon-14. Because if I move it, what is that going to tell me? Like, this doesn't even go to 0%. The lowest it goes is 10.9%, right? So I can't use carbon-14. So what I'm going to do is I'm going to try another isotope. So to do that, I select, underneath that I have uranium-238, and bam. When I select that, I get 97.9%. So once again, I'm going to now try and match, now that I have a percent here, I'm going to try and match the percent to the plot here, but I need to make sure that my plot is reading close to 97.9%. So I'm going to move this over to the left since I want to increase the amount. That's 90%. We're still not quite there. That's 96. 97.8. That's close enough. All right. So now I'm going to go ahead and put in my time. Notice that this has MY What do you think that MY stands for? That stands for million years, okay? So this is saying that this is, this rock is 149.97 million years old. Now, what if I just go ahead and put in 149.97? Oh, that's not coming up. Okay, so why is that? Well, that's because this number right here is 149, but I need it to be 149 million. So remember, whenever you're typing in millions, you should have 6 zeros or 6 digits after the ones place, but 6 digits after the decimal, right? So there should be, to make this a millions place, I'm going to go ahead and click on it to correct it. So I'm going to put 149. I'm actually going to ignore the number after the decimal. So I'm just going to write 149, or I can round it up even to 150. So this 150 is rounding the 149.97, so it's 150. And then millions, I got to add 1, 2, 3, 4, 5, 6. All right, so for millions, you're going to add 6 zeros. And for billions, you would add 9. Okay, 1500000. So this is the number I'm going to put into my data table. I could have also put in 149. So let's, if we wanted to check it, let's try it this way. 149. 1, 2, 3. Actually, I'll put the 97 as well. 97. 1. Okay, check this minute. Again, it's going to be correct. All right, so I'm just going to go ahead and round it to 150 million. Okay, the next one I'm going to do is I'm going to do, the last one I'm doing is the fish. So I'm going to find the fish. All right, here it is. I put the Geiger counter on it and it says 0%. So what does that tell you? You need to change it. All right, so let's go ahead and try carbon-14. Oh, that's also reading 0%. So both carbon-14 and uranium-238 do not work because there's 0% of those isotopes in that fish. So I'm going to click on custom. Now when you click on custom, you'll notice that like right now it's reading 82.4%. So that means I could use that one. But let's say my custom started here and it said 0%. So if you have a case where you tried carbon-14, you tried uranium-238 and it's still not working, and you go to custom and it's still not working, then what you need to do is use this drop down menu and change the half-life. So this half-life is 100,000. Let's try 1 million. Still not working. Okay, let's try the 10 million. I get 14.4. So I could actually use this one because it's 14.4. So what I could do is move this over until it matches 14.4. And I get 27.95 million. So let's go ahead and put that in and see what happens. Now that I put that in correctly, 2.27 let me just make sure. 95, I put that in correctly. What do you think? Nope, I didn't. Remember, if it's million years, you have to add 6 zeros. So let's go ahead and do this again. Let's do 27, and I could round that up to 28. So because this is 28, and then million, 1, 2, 3, 4, 5, 6. Check my estimate. All right, so that's the number I'm going to put in my table. Okay, so for millions, you want to have 3 zeros. If it's billions, you would have, if this was billions, you would add another 3 zeros after that. Okay, so I hope you found this video helpful on how to do all this. And if you have any questions, let me know. Have a quality day.